So, hello everyone. Today we are going to discuss the questions of P block elements. Okay. So first question is, discuss the pattern of variation. Discuss the pattern of variation in the oxidation states from boron to aluminium. So boron to aluminium means it is group 13. Now in group 13, the electronic configuration is ns2 np1, is ns2 np1. Okay, so group oxidation state is +3, right? But when we go down the group, due to inert pair effect, keep in mind, due to inert pair effect, what happened? Due to inert pair effect, s electron pair becomes inert, and that's why +1 state, oxidation state, stability of +1 oxidation state increases. That's why they see common oxidation state is +1 and +3, and stability of +3 oxidation state decreases, and +1 oxidation state increases from boron to aluminium. It is due to inert pair effect. Okay, so this is general pattern. Okay, now come to carbon to lead. So carbon to lead, that is a group 14, and its electronic configuration is ns2 np2, right? So common oxidation state is +4 group oxidation state, and as we go down the group, what would happen? You know that s electron pair becomes inert, again due to inert pair effect, and +2 oxidation state, stability of this oxidation state increases. So this, the common oxidation states are +4 and +2, and stability of +4 decreases from carbon to lead, and +2 oxidation state increases, right, from carbon to lead due to inert pair effect. So this is question number 1, okay, of exercise of NCERT of P block elements and class 11, right? Next, how can you explain higher stability of BCl3 as compared to TlCl3? Same reason, due to inert pair effect. Okay, so as we go down the group, inert pair effect increases, and this inert pair effect is maximum in thallium. Why is it so? Because in thallium there is presence of D as well as F electrons, and in boron no D and F electron is there. So no inert pair effect in boron, but maximum inert pair effect in thallium. That's why thallium is more stable in +1 state. So TlCl is more stable than TlCl3. Okay, but in case of boron, BCl3 exists, but BCl does not exist. That means BCl3 is more stable than TlCl3. This is the reason. See, BCl3 is quite stable because there is absence of D and F electrons in boron, and 3 valence electrons in 2s2 and 2p1. Okay, and they are there for bonding with chlorine atoms. In thallium, valence s electron pair are experiencing maximum inert pair effect. That means this pair becomes inert, not participating in bonding. Thus only 6p1 electron is available for bonding, and that's why BCl3 is stable, but TlCl3 is comparatively less stable, or we can say unstable. Done. Next, why does BF3? It is boron trifluoride. Okay, means BF3 is given. BF3 behave as Lewis acid. What is Lewis acid? The Lewis acid is the one which can gain electrons. Okay, so So that means that compound should be electron deficient. Okay. So see, in BF3, boron is attached to 3 fluorine atoms. So how many valence electrons are there in boron? Boron has 3 valence electrons and 3 are shared with fluorine. So there are total 6 electrons. Okay. That's why it is deficient of electrons, means octet is not complete. As octet is not complete, so such substances are called electron deficient compounds. So it is an electron deficient compound, and that's why it can accept electrons, okay, and behave as a Lewis acid. See, given central atom means boron has only 6 electrons after sharing the electrons with fluorine, and that's why it is an electron deficient compound, because octet is not complete, and that's why it behave as a Lewis acid. Okay, that's why BF3 can react with ammonia to form an adduct like this. BF3, it accept electron pair from nitrogen, right? And that's why it forms an adduct. So ammonia act as a Lewis base, BF3 act as a Lewis acid. Okay. Then come to question number 4. Consider the compounds BCl3 and CCl4. How will they behave with water? We have to justify. See, BCl3 is electron deficient, that you know, because boron has 3 valence electrons. 3 electrons are shared with chlorine. So total electron it has are 6. That means it has incomplete octet. So it can accept electron pairs from water. So it forms boric acid along with HCl. Okay. But CCl4, in CCl4, carbon form 4 bonds, 4 valence electrons, 4 are shared with chlorine, so it has complete octet. Okay, that's why it cannot accept, it has no tendency to accept electrons from water. Okay, that's why there is no reaction at all. See, BCl3, there is only 6 electrons in the valence shell of boron, therefore octet is incomplete, so it can accept pair of electrons from water, and therefore BCl3 undergoes hydrolysis to form boric acid and HCl. Okay, but in CCl4, carbon has complete octet, that's why it has no tendency to accept electron pair from water, when no reaction is taking place. Okay, next question, is boric acid a protonic acid? What is protonic acid first? So keep in mind, protonic acid means which can give proton, like HCl. HCl when dissolved in water, we get H plus and Cl negative. So HCl is a protonic acid. H2SO4, it can also give H plus ion. So it is also a protonic acid. HNO3, it can give H plus ion. So it is also a protonic acid. They are all protonic acids. But when you talk about boric acid will not give H plus ion. Rather, it accept OH negative ion from water. BOH thrice, see, BOH thrice. So it is deficient of electron. So it can accept OH negative from water. Okay, means it accept electron pair, means it form BOH4 negative, and then H plus ion is provided by the water itself. Okay, or you can write H3O plus if you write 2HO H2O. ठीक है ना? So boric acid will not give H plus ion, rather it accept electron pair, or we can say it can accept OH negative ion from water. So it is a Lewis acid. It means H plus ions in the solutions is provided by the water, right? That's why it is not a protonic acid, rather it is a Lewis acid. Got it? Next, what happens when boric acid is heated? So see, boric acid, when we heat it, first of all, it gives metaboric acid. It gives metaboric acid along with water. Okay, after getting metaboric acid, if it is further heated, see, when metaboric acid is further heated, above 370, okay, then we get boric oxide along with water. Okay, in between tetraboric acid is also formed, but main products are, first when we heat it, it gives metaboric acid, okay, and then on further heating we get boric oxide. Done. Next, question number 7. Describe the shapes of BF3 and BH4 negative. Assign the hybridization of boron in these species. So in BF3, it has 3 bond pairs, and boron has 3 valence electrons. See, as 3 fluorine are attached to boron, so it has 3 bond pairs. All the 3 electrons of boron are involved in bonding, so no lone pair. That's why 3 bond pairs, no lone pair. So it has a trigonal planar, right? And what is the hybridization of boron? So see, boron forms 3 bonds, forms 3 covalent bonds, okay, with fluorine. That's why hybridization is sp2, right? So in BF3, boron has sp2 hybridization and trigonal planar shape. Okay, now BH4 negative. So in BH4, it is BH4 1 negative. Okay, so in BH4 1 negative, how many bond pairs are there? 4 plus valence electrons. Boron has 3 valence electrons and 1 negative, means 4 valence electrons total. Okay, all the 4 are used, so no lone pair. That's why boron it is like this. Okay, all the 4 bond pairs, no lone pair, means regular geometry, so it has tetrahedral geometry. Okay, and as 4 bonds are formed, so hybridization is sp3. So boron is sp3 hybridized and shape is tetrahedral. Done. Now question number 8. Okay, number 8. Write the reactions to justify amphoteric nature of aluminium. So you know, aluminium is, it can react with acid as well as base. Aluminium can react with acid as well as base. So that means if with acid it acts as a base. Aluminium can react with acid as well as it react with a base. That's why it shows its amphoteric nature. Okay, so when aluminium react with HCl, so what happened? Aluminium give aluminium 3 plus along with 3 electrons, and out of HCl, H plus ion accept electron to form H2 gas. In this way, AlCl3 and H2 gas is formed with HCl. With Al sodium hydroxide, first we get AlOH thrice, but AlOH thrice formed, further dissolved in sodium hydroxide to give NaAlOH, okay, along with hydrogen gas, right? Got it? So this is question number 8. Next, what are electron deficient compounds? As I said earlier, electron deficient means which has electron deficiency. So you know, if it has less than octet of electron, okay, so that is electron deficient compound, okay, or if it has vacant d orbital even, then it is an electron deficient compound, okay. So now let us see, you know, BCl3, it is quite obvious that it is electron deficient because it has only 6 electrons. We have done so many times, okay. And if you talk about SiCl4, see, SiCl4, though silicon has now 8 electrons in its valence shell, but as it has vacant d orbital, if it is carbon, then it is electron precise, but silicon has vacant d orbital, that's why it is also considered as electron deficient compound, because silicon can accept electron pair. That's why SiCl4 can be hydrolyzed, okay. Got it? That means BCl3 is electron deficient because it has electrons in its valence shell after combining with the chlorine less than 8, that is 6. SiCl4, though it has 8 electrons in its valence shell, even though it is electron deficient because it has vacant d orbital. So see, it is written, electron deficient species are those in which central atom in their molecules has tendency to accept one or more electron pairs. You should write like this: if that central atom in the given molecule has tendency to accept a pair of electron, one or more pair of electron, that means that is electron deficient compound, and they are known as Lewis acids. So BCl3 as well as SiCl4 both are electron deficient species. Since in BCl3 boron has only 6 electrons, therefore it is electron deficient compound. But in SiCl4 central atom has 8 electrons, but that can expand its covalency beyond 4 due to the presence of d orbitals. That's why that is also considered as electron deficient species, right? Now question number 10. Question number 10 is, write the resonance structures of CO3 2 negative and HCO3 1 negative. Now in CO3 2 negative, you know, if you write the structure in CO3 2 negative, there are 3 bond pairs and how many lone pairs? See, carbon has 4 valence electrons, 2 electrons are gained, so 6 valence electrons on carbon. Out of 6, all the 6 are used because each oxygen share 2 electrons. So total 6 electrons are used, so no lone pair. So when you write the structure, see, first of all write like this: Now as two negative charge, that means there are two single bonds and one double bond. Number of negative charge is equal to number of single bonds with oxygen. Okay, and to complete octet, see, it needs 3 pairs, 3 pairs, and double bonded oxygen needs 2 pairs. So that double bond may be anywhere at this position, this one, or this one. Okay, that's why structures are like this: 1, 2, and 3. Okay, and what happened with the resonance? Due to resonance, bond order is averaged. So you can write its resonance hybrid. These are resonating structures, okay? And resonance hybrid you can write after writing these structures as, when there is partial double bond character. So bond order is equal to, how many bonds are between C and O? 1, 2, 3, 4. Total number of bonds divided by total number of positions. How many positions are there? 1, 2, 3. That is 4 by 3, means 1.3. 3 ones are 3, 10, 3 threes are 9. 1.33. Okay, so bond order of CO is 1.33, means is more than single and less than double. Got it, beta? So resonance averages the bond order as well as bond length. So bond order is calculated by using this formula, but total number of bonds between two atoms divided by total number of positions. क्या बोला मैंने? बॉन्ड ऑर्डर इज इक्वल टू टोटल नंबर ऑफ बॉन्ड्स between carbon and oxygen divided by total number of positions occupied by bonds. Okay, now HCO3 1 negative. So in HCO3 1 negative, this case, see, obviously there is one double bond, and out of two oxygens which are singly bonded, one is attached to H plus, because it is like this. See, you write the structure. See, it is like C double bond O, okay, O negative, O negative. Okay, now when H plus is attached, so one of the negative is replaced and there is H. Okay, so one negative charge, or this may be reversed. C double bond O, O, OH. That's it. So there are two resonating structures for bicarbonate and one resonating structure for carbonate. So these are the 10 questions. Just complete them, then we will do next question. Okay. Bye for now. God bless you all.